Hello everyone, welcome to Geeky Nerd. Today we will begin with the part 5 video of time, speed and distance. Before moving into the video, I hope everyone would have become thorough with the previous videos related to this topic. If you have not seen them, click on the card or the links in the bio. In this video, we will deal with three different concepts, that is, how to determine the extra distance traveled by one object in relation to another. What is the relationship, that is, the ratio of the two speeds, and how to determine the speed of an object with and without the stoppages. Like, share, and subscribe the channel for more interesting concepts and shortcut methods for solving them. So, without wasting any time, let's head into the video. This concept can be referred to as extra distance traveled or the distance covered to meet each other. Let us read the statement first. When two persons A and B travel from points P to Q, whose distance is d, with speeds A and B respectively, B reaches Q first and returns immediately and meets A at R. So the question says that there are two persons, namely A and B. Both of them travels from P to Q. The distance between P and Q points is d. Let small a be the speed of person A and small b be the speed of person B. Now, since B travels with higher speed, what it does is it reaches Q and returns back to a point R. So B reaches Q and returns back to a point R where A manages to go just from P to R. When both A and B meet, what is the distance covered by A and what will be the distance covered by B is the motto of the question. So distance covered by A is equal to PR and distance covered by B is equal to PQ plus QR. So distance covered by APR is equal to 2D of A by A plus B. Similarly, distance covered by B, that is PQ plus QR, is equal to 2D of B by A plus B. So with this concept, we can clearly identify what is the distance traveled by a high-speed object and the low-speed object when they eventually meet with each other. So let us solve some examples to know how this concept operates in reality. Sono and Mono travel from point P to Q at a distance of 42 kilometers at 6 km per hour and 8 km per hour respectively. Mono reaches Q first and returns immediately and meets Sono at R. Find the distance from points P to R. So from the question, we can understand that total distance between P and Q is equal to 42 kilometers. Speed of Sono is equal to 6 km per hour. Speed of Mono is equal to 8 km per hour. We need to find distance from point P to R. So from the question we can see that Mono travels quicker when compared to Sono. Therefore, the time take Mono first covers the distance PQ and then returns from Q to the point R where he meets Sono. Sono just moves a distance from the points P to R. In such cases, we had read in the concepts that distance covered by Sono, that is PR, is equal to 2 times D of A divided by A plus B. So we know the distance as 42. Therefore 2 into 42 We know Sonu speed as 6 km per hour divided by 6 plus 8. Upon solving this we get 84 into 6 by 14, which will give us 36 kilometers. Thus, with respect to the speeds of Sono and Mono, we had found the distance covered by Sono, PR is equal to 2d of A divided by A plus B, which in turn will give 36 kilometers. Had they asked the distance covered by Mono in the question, we could have used this formula. Distance covered by mono, that is PQ plus QR is equal to 2D of B by A plus B, which in turn will give 2 into 42 into B is 8, therefore 8 by 14. This can be solved and we can get the answer as 48 kilometers. Therefore, the distance covered by Mono according to his speed is equal to 48 kilometers. In case if they ask the extra distance traveled by Mono, we can subtract the two distances and give it as 12 kilometers. Thus, we can clearly say that the distance covered by one person with respect to another can be initiated using the formulae which we discussed in this concept. Ratio of speeds of two objects s1 and s2 is inversely proportional to the square roots of their time taken. That is, s1 by s2 is equal to t2 by t1 the whole power half. That is, s1 by s2 is equal to whole root of t2 by t1. We know that speed is always inversely proportional to time. Therefore, this equation is arrived as s1 by s2 is equal to whole root of t2 by t1. While solving the problem with respect to the ratio of speeds, we need to consider 2 points curiously. That is, if two objects have their speeds in the ratio A is to B, distance covered by the two objects will also be in the ratio A is to B, and the time taken by the two objects will be in the ratio B is to A. The first point says that if the ratio of the speeds of two objects is equal to A is to B, then under same time frame, the distance covered by the two objects will also be in the ratio of A is to B, whereas the time taken by the objects to cover the distance would be in the ratio of B is to A, since speed is inversely proportional to time. This ratio of speeds or ratio of time taken or ratio between the distances can be applicable only when any one of the three entities is constant. That is, only when speed or distance or time remains constant, then the sum can be solved utilizing the ratio concept. Let us solve some examples to understand how this works out. Two trains A and B travel from points X to Y and the ratio of the speeds of A to that of B is 2 is to 7. Find the ratio of the time taken by A and B to reach X to Y. So, from the question, it is given that two trains A and B travel from points X to Y and the ratio of speeds of A to that of B is 2 is to 7. Therefore, speed of A is to speed of B is equal to 2 is to 7. So here from the question, we can identify that the distance remain constant. So, distance remains constant. Henceforth, as per the concept, when D remains constant, S1 by S2 is equal to T2 by T1. Therefore, S1 by S2 is equal to 2 by 7, which is equal to T2 by T1. Therefore, T1 is to T2 is equal to 7 is to 2. We can also say that when distance remain constant, the ratio of the two speeds A is to B can be interpreted in terms of time taken as B is to A. Thus, speed is inversely proportional to time and hence the ratio value of speed gets inversely proportional with respect to time taken as distance remains constant. Let us solve one more question. A man sets out to cycle from points P to Q and at the same time another man starts to cycle from points Q to P. After passing each other, they complete their journeys in 9 hours and 4 hours respectively. Find the ratio of speeds of first man to that of second man. So from the question, we can see that T1 is equal to 9 hours, T2 is equal to 4 hours. So here we can understand from the question that distance remains constant. Therefore, when D remains constant, S1 by S2 is equal to square root of T2 by T1. On substituting the known values we get S1 by S2 is equal to square root of 4 by 9. Therefore, S1 by S2 is equal to 2 by 3. Thus, here too we can see clearly that the time taken becomes inversely proportional to that of the speed. Whenever we try to solve the problems related to ratio of speeds, we need to keep the point in mind that any one of the three entities of speed, distance and time taken should be constant. Let us move on to the next concept, speed without stoppages. When a train travels a distance at a speed of s1 km per hour without stoppages, with stoppages, it covers the same distance at a speed of s2 km per hour. It has been given that without stoppages, the train travels with speed of s1 and it covers a certain distance. The same distance is covered by the train at a speed of s2, including its stoppages. Now we need to know the stoppage time per hour. So, the stoppage time per hour can be related by the formula S1 minus S2 divided by S1, where S1 is the speed of the train without stoppages and S2 is the speed of the train with stoppages. We know that speed of the train without stoppages will always be greater than the speed of the train with the stoppages. Therefore, S1 will be greater than S2. Therefore, S1 minus S2 divided by S1 is equal to difference of speed divided by speed without stoppages. If we solve this equation, we will in turn get the stoppage time per hour. Let us solve some examples to understand this simple concept. A train travels at the rate of 50 km per hour without stoppages and it travels with a speed of 40 km per hour including the stoppages. For how many minutes does the train stop on an average per hour? So from the question we can easily identify that speed of train without stoppages S1 is equal to 50 km per hour. speed of train with stoppages S2 is equal to 40 km per hour. We need to know the stoppage time per hour is equal to difference in speed, the whole divided by speed without stoppage. That is S1 minus S2 divided by S1, which is equal to 10 by 50, which is equal to 1 by 5 hour. So in terms of minutes, it can be expressed as 12 minutes. Therefore, the train stops 12 minutes on an average per hour. Through this video, we learned how to determine the extra distance traveled by one object in relation to another, how the ratio relationship exists between two speeds, and how to determine the speed of an object with and without the stoppages. Problems were solved via both shortcuts and traditional methods, and viewers can choose any one of them depending upon their convenience. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can be benefited. Until we meet in the next video, thank you.